Okay, now we're going to go ahead and look at the last inequality type. And this is how we would solve, and all these are on page 126 of your textbook. If you want to see the inequalities written out, and we're still in 1.7. And this is one where it points to the left. So this one's going to point to the left. Now, if it points to the left, then you solve this. AX plus B is in the middle, and it's trapped between a minus K and a positive K. And my answer is here in the middle. So if it points to the left, your answer is going to look like this in the middle. If it points to the right, they'll go out in the left and the right directions. Okay, so if it points to the right, we did a minute ago. If it points to the left, then we solve this double inequality or three-part inequality like that. Okay, so let's now go ahead and work through a few of these. What you have to do is you have to keep track of which way it points. So absolute value of about x minus 7 is less than 4. So when we go to solve this one, notice it points to the left. And that's very, very important. What you look at is which way this inequality points. It points to the left. If it points to the left, then you have to solve a three-part inequality. And that just means your inequality, your absolute value, your inequality here is going to be sandwiched between positive 4 and the negative 4. So we just solve it. So we add our 7. And then minus 4 plus 7 makes it 3. X is in the middle. And 4 plus 7 makes it 11. And the only difference is now, if it points to the left, you shade in the middle. If it points to the right, you shade on the edges. So this one points to the left. So we shade in the middle. So what does it look like? It looks like here's 3 and here's 11. We shade in the middle. We're going to use parentheses. And then in interval notation, it's 3 to 11. With parentheses on both. Let's do one more of these, and then I'm going to start mixing them up. And then you're going to have to tell me which one it is. We'll do one more like this, and then we'll kind of mix them up and give you 3 or 4 of all the types mixed together. Now again, what does it do? It points to the left. And if it points to the left, what do? Well, we have to solve it as a three-part inequality. So our 5x plus 1 stays in the middle. And then we have a minus 9 and a what? Positive 9. solve it, move things around. Move that 1 over everywhere. And then we've got a 10. Sorry, negative 10's on the left, right? We got a 5x in the middle. And we have an 8 on the right. We divide by our 5. And we break it down then into a minus 2 on the left. X is in the middle. 8/5 is on the right. Put them on our number line. Graph them again, we use parentheses. The next one we use square brackets on. This one uses parentheses here. And we've got a minus 2, comma, 8/5, also with parentheses. So that's going to be your answer right here. Now, the next 3, I'm going to mix them up. And we've got to figure out which one we're going to use. Whether we use the 2 separate inequalities, or whether we have something like this. And it's based upon whether it points to the left or it points to the right. And you might also have to move numbers around as well. There might be a number that has to be moved over. So let's just do 3 of these. And then we'll talk about special cases. So, when I see this type of problem, doesn't matter whether it's an inequality or an equal sign, that absolute value needs to be by itself. So, what do I need to do with that 8? Move it, right? Because the absolute value has to be by itself on the left. So, move that 8 over. So that's the first thing you do. Absolute value must be by itself on the left. Now, which way does it point? Okay, it is pointing to the right. So if it points to the right, that means you've got 2 separate inequalities. So it points to the right. So we have 2 separate inequalities. And this one I made really easy. There's hardly anything to do. So this one has 2 separate inequalities. What are they going to be? Minus 2x is greater than or equal to 18, or minus 2x is less than or equal to a negative 18, right? Why do we have the 2 separate inequalities? Because which way does it point? It points to the right. If it points to the right, what do we have? 2 separate inequalities. What do we do next? Yep, divide by that negative 2. And what's that going to do? Flip the signs, isn't it? And the inequality symbols. 18 divided by negative 2 is a negative 9. Divide by your negative 2. And flip your inequality. Negative 18 divided by negative 2 makes it a positive 9, doesn't it? Now, what does it look like? We have to remember what it looks like. What does it look like? If it points to the right, that means it goes out in each direction. We can graph it if you want. If you want to put these on a number line, graph them, you can. But just remember, if it points to the right, it goes out to the right. Both directions, left and right. So negative 9 is here. Positive 9 is over here. Now, we have square brackets. And look at this one. Okay, negative 9. Which way does it point? Points to the right. Shade to the right. Look at positive 9. Which way does it point? Yeah, sorry, this one points to the left. Let me say it correctly. This one points to the left, so we shade to the left. This one points to the right, so we shade what? To the right. Okay, how do we write our answer? We have to use that union. So it would be negative infinity, comma, negative 9 with square bracket, U for union, square bracket, 9 to what? Positive infinity. So the way that the inequality symbol points, that determines which way we write the inequality. And so, let's try another one. Okay, now, what about this one? Is there anything to move over? Nope, nothing to move over. Okay, so what do we want? Well, which way does it point? Points to the left. If it points to the left, we have that three-part inequality. So what does our three-part inequality look like? Well, x minus 8 goes in the middle. And then we have a negative 15 and a positive 15. Look, negative is always on the left. That's why the 15 is here. Negative. Okay, so whichever way it points dictates whether it's shaded in the middle or whether it's shaded on the edges. So this one pointed to the left. So this made a three-part inequality. We're going to add our 8 over. And now we've got minus 15 plus 8. That leaves you with a minus 7. X stays in the middle. And 15 plus 8, that leaves you with a 23, I believe. Okay. And what is it going to look like? It's stuck between them. On the number line, make sure they're in the right order. Negative 7 is here. Positive 23 is over here. And they're going to get which one? Brackets or parentheses now? Square brackets, right? Why do they get square brackets? Yep, greater than or equal to, less than or equal to. There we go. And what does it look like in interval notation now? It looks like negative 7, comma, 23, also with square brackets. Okay, let's do one more of these, then we'll look at some special cases. And that'll finish up the lecture for today. I'll be posting a worked out copy of your practice exam. So that way, we didn't really have time to cover a lot of it, or probably won't have time to cover any of it today, but I'll post it online how I worked out all the pieces, just like the notes. And then next week, before we take our exam, you can ask questions over it. Now let's go ahead and do one more of these. Okay, so which way does it point? Okay, points to the left. If it points to the left, what do we need? 3 parts. And remember, on your exam, you can have notes. So if you want to write down an example of one of these, like this one, and how you worked it out, you can do that. You can either have a page of notes or a set of note cards. So if you want to bring in 15, 20 note cards with multiple examples, you can do that. Or you can have a page of notes, either way. And we'll talk more about that before we leave today. So here's our inequality. We said it points to the left, so that means it's a three-part inequality. So that means that 3x plus 4 goes in the middle. And then we've got a negative 4 on the left, positive 4 on the right. Move things around. And the left-hand side makes it a negative 8. 3x is in the middle. And the right is 0. Let's go ahead and divide by our 3 everywhere. That makes it minus 3/8. X is in the middle. And 0 divided by any number is still 0. Number line, we need a minus 8/3. And a 0. Brackets or parentheses on this one? Parentheses. And right in between them is going to be our answer. And then in interval notation, we've got minus 8/3, comma 0. Now we're going to revisit some special cases. And we've talked about the special cases before break when we looked at the equalities. And we talked about little special cases with those. We're going to review that one, and then we're going to add a couple more. Let's talk about the special cases. And the special cases are when the right side is negative. So these are special cases when the right side of the absolute value is negative. And the solutions are either the empty set or everything. It's either nothing or all of it. So these are going to be special cases. And these special cases are when the number on the right, outside of that absolute value, is a negative. And 0 falls into this too, but we'll deal with 0 by itself in a moment. Okay, so we already talked about this one. Absolute value of, let's say, 1/3 x plus 9 equals negative 15. We do not need to solve this one. This is a very, very commonly missed question. You can't solve it, right? We don't have to do any work at all. When we look at these absolute values, we need to first make sure that that number is positive on the right. If it's negative on the right, we don't have to do near as much work, and it's a simple problem. It's negative, right? It equals a negative number. We know that absolute values can never equal a negative number. So that's false, right? Absolute values have to be positive. They can never equal a negative 15. So then that means this absolute value has what? No solution. Okay? Doesn't matter what's in it. Do we have to work it out? No. Why not? That's negative. Now let's talk about inequalities. Again, these are going to be special cases. Absolute value of, let's say, 1/9 x plus 8/3 is less than negative 15/8. When I look at this problem, it looks like it's going to be a lot of work. We have all these different fractions, all these different denominators, but we're not going to really have to do anything. Why not? Because this is what? Negative. That makes it a special case. So, what do we know? And this is the way I figured these out, if it's true or false. What do we know about an absolute value? When I take an absolute value of a number, what comes out of it? If I take the absolute value of 12, what comes out? Positive 12. If I take the absolute value of negative 15, what comes out? Positive 15, right? So what comes out of these inequalities, or these absolute value inequalities? Positive. Okay, now, tell me if this is going to be true or false. Are positive numbers, are they smaller than negative 15/8? Is that true or is that false? False. Okay, so that is false. So that means we have no solution. Do another one. We'll do probably 2 or 3 more of these, just to make sure we understand how they work. Then we'll quickly look at 0 and look at some of the questions from your homework. Okay, well, when we first look at this, we might think maybe it's solvable. But before I can do anything else, before I even think about solving it, what do I need to do first? Okay, have to get that absolute value by itself on the left. It must be alone. So move that 15 over. Now, when you move that 15 over, then it makes it what? Yep, negative, and that makes it now a special case. Because that makes it a negative 13 on the right. Okay, special case. Why is it a special case? Because that is negative. What do we know about absolute values? We assume they come out to be positive. Are positive numbers, are they bigger than a negative 13? Is that true or false? Positive numbers are bigger than negative 13, aren't they? So that would make it true. Okay, if it's true, that's like an identity. And that means your solution set would be negative to positive infinity. Not much at all to do on these. If it's negative on the right, it's a whole different problem, and it's easy. Let's look now at 0. Same concept is going to hold for 0. Okay. So, again, 0 is like another special case. What do we know about absolute values? What do they give you out? Positive numbers, right? Are positive numbers, are they bigger than 0? Is that true or false? True, right? Positive numbers are always larger than 0. So what would my answer then be? If it's true, it is what? Negative to positive infinity. What about if I flip the sign around? Yep, and let's do one where we have to flip it around, so you can see the difference here. Okay. Absolute value of minus 3x, less than 0. What do we know about absolute values? Absolute values are positive. Are positive numbers, are they going to be smaller than 0? Can that happen? Nope. So that would be what now? False. And so that means you have what? No solution. So be careful with these. The first thing I always like to do is get that absolute value by itself on the left. Then I see if it's positive or negative. If it's negative, it's a whole different type of problem. If it's positive, then we figure out how to solve it based upon the inequality or the equality. I do want to now touch base with you on a couple of questions from our homework, just to make sure we know how to solve these. I'm going to go through with you question number 8. So this is on your homework. And I think there's another one like this in here as well. If I remember right. And maybe there's just that one. I think there might just be this one, but I want to make sure we understand this concept again. This goes back to what we just looked at a minute ago. It's just written with variables instead of numbers. Now they want you to tell me how many solutions that this is going to have. And we're going to look right here at the condition. And what does it say? It says if k is less than 0. So let's pick a number that's less than 0. Doesn't matter what we use. Let's use k equals negative 3. Is negative 3 less than 0? Yeah. Okay. So we're going to use negative 3. You can use any number. It just tells us that k has to be less than 0. So we're going to pick a random number that's less than 0. And we're going to see how we would solve this absolute value here. Now, if I chose that negative 3, because negative 3 is what? Less than 0. I could have chosen negative 20. It won't matter. As long as you pick a value that is less than 0. That's what it says. Okay, it's got to be less than 0. What about this one? We just did these a moment ago. It's an equal sign. Can absolute values ever equal a negative number? No. So this is going to be what now? False. No solution. Okay. All you have to do. So there's no solutions. That's what they wanted on that one. I'm going to help you do question 12. You're going to have to do question 14 on your own, but they're very, very similar. What we look at here, and you can either use how we've done these before, or you can use this table on page 128. Or sorry, 126. If you look in your textbook on 126, there's these different cases. Now, we've already done these. And we've talked about them, we've solved them out. This is what we used a minute ago. We need to figure out which one of these does this come from. Okay, now look at this. Which way does it point? Points to the left. Okay, now if it points to the left, what does that mean? Okay, if it points to the left, then that means it's in the middle. And that's a three-part inequality, right? Because if we look here, this looks like, and it looks like case 3 in our textbook, doesn't it? And so that's what it looks like. Now, be careful about how you write it. The A plus B is in the middle. The negative is on the left, positive is on the right, and look at the way they open. Okay, they open the same direction, so it opens all to the right. Right? Make sure it goes that way. So when we look here, we got to make sure that we can get the correct one. We know for sure that it's not A and it's not D. Those don't even look right at all, so we know those are done. Now, what is the difference between B and C? Yep, they need to go the same direction. This one's not going to work because they all need to go to the right. When you look from left to right, they need to all open to the right. So this is not going to work. So which one is it going to have to be? Has to be B. You're going to do the exact same procedure for 14. So 12, your answer is going to be B. 14, I'm going to leave it for you to do, but look at 14. The inequality points the opposite direction. And be very careful on this one. When you look it up, make sure which way you've always written them. Have I ever put an and in between them? No, I haven't, have I? Every time I work them out, what do I always be careful to put down in between them? Or. So you can always already eliminate B and D. And you need to figure out if it's A or if it's C. That should now get you to be able to solve all of these absolute value equations and inequalities. So you've covered them all. What's going to be our homework? Okay, our homework now is going to be finish up that packet. So 1.7, you're going to want to do them all, and also work on the practice exam. Okay, our first exam is next week. What can we have on our exam next week? Well, you can have either a page of notes, or note cards. I don't really put a limit on the number of note cards because I'd really prefer that you make note cards. I think it's a much better way to study. You just don't want to have too many. I mean, don't try to bring in like 50 note cards. You shouldn't need that many, but use your best judgment. Make up your note cards. On the note cards, if you want to put a problem on the front and how you worked it out on the back, you can do that. That way you have an example of this absolute value. So, for example, if you wanted to go back and put, let's say, this problem right here on the front of a note card and how you worked it out on the back, you could do that. Okay? You could put that on a note card. You can use that on your exam. So you can have a page of notes or note cards. You'll want to make sure that you bring in a calculator. I always have extra calculators, but whatever calculator you're used to, you want to bring that in because you're used to using it and you don't want to have an extra stress factor on your exam of using a different calculator. So whatever calculator you've been using, bring it in. So you can have a page of notes front and back. You can have a calculator. And you'll also want to bring some scratch paper. So if you want to bring in some lined notebook paper, you can use lined notebook paper. You can use typing paper, it doesn't matter. But those are the three things you can have. Page of notes or note cards, a calculator, and some scratch paper. Now next week, what else am I going to pick up? I'm going to pick up your entire Chapter 1 packet. So that's what's also going to be due. So next week, you want to bring back your completed Chapter 1 packet. So make sure you bring in that completed Chapter 1 packet. On exam days, we don't go over new material. So what we'll do is we'll come in, we're going to review some of the old material. So if you've got questions on your practice exam or questions out of your homework that we covered in 1.7, you can ask those questions. Then we'll take a break, and then you'll have plenty of time to take your exam. So you're not going to feel rushed at all. You'll have probably about hour, 45 minutes, or 2 hours to complete your exam. It shouldn't take that long. Now, your exam is going to look very, very similar to the practice exam. Almost exactly the same. Just on your practice exam, I have 25 questions. I'll probably either cut that down to 20 questions, or I might just make it like 22 questions and you can skip 2 of them. But you're only going to have to do 20 questions. I'll either cut out 5 of the questions, or I'll maybe leave a couple and then let you skip whichever one you don't want to do. But they're going to be very, very similar. If there is an inequality on your practice exam, there's going to be a very similar inequality on your exam. If there's a mixture problem on your practice exam, there's a mixture problem on your real exam. Pretty much the same, different numbers in a different order. I'm going to be posting, when I post the notes up, I'm going to post a worked out copy of your practice exam. So I'll go through and work out all the questions on your practice exam so you can see how I did each step. I may not get to that today, but I'll be sure and get to that at the latest tomorrow. And I'll post the video today, so you'll be able to look at the notes in the video today. I may or may not be able to get through working out the practice exam today. It might be tomorrow. But I'll post those in Canvas. So I will see everyone then next week and prepare for that exam. If you study that practice exam, you'll be fine. Very, very similar to the real one. It's just there'll be 20 questions.